All right, let's work on the next problem of the day. This is LeetCode number 128, the longest consecutive sequence. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O of n time. Let's see. So, longest consecutive element sequence is 1, 2, 3, and 4. Therefore, its length is 4. Okay. And in the bottom one, we can go 0, 1, 2, 3, 4, 5, 6, 7, 8, right? Okay, and we need to write an algorithm that runs in O of n time. Let's see. So first I'll say, feels like a hashmap problem. I feel like I've done this before. I feel like I've done this problem before, and it was either a hashmap or a hashset problem. Especially with the O of n runtime. So with O of n runtime, sorting is out. Let's see. Any sorting is out, really. And then let's see what else we could do. If we wanted to hash them out, then we'll say iterate over the array in a first pass. If the array or keep track of the maximum value we've encountered so far. Then we can say add all of the items into a hash set. I'm going to go with the set for now because I don't think we need the map component. If we keep all those, in the hash set, then we can say from 0 to max, what we can do is that if an item exists within the within the set, increment a counter for sequence length. If such an item does not exist, reset sequence length to 0. So the idea is that we'll add 100, so 100, 4, 200, 132. We'll go from 1 to 200, or 0 to 200. Well, this isn't really a viable option because our values can range from -10 to the 9 to 10 to the 9. So I don't think that this is actually a viable option then. So this part of the checking needs to change. This part of the pass. If we had a map instead, keeping track of the length of the sequence, initialized to 0, what would be the clause, or what would we check? If a value exists which is 1 higher or 1 lower than if the value exists which is 1 higher or 1 lower than the current value, our sequence length at that is equal to the length of the previous plus 1. So then we can say for all items within the map, find the max. In that case, find the max value. So what this will do is that if we do 104, 200, 132, then in our map, we'll have 100 set to 1, 4 set to 1, 200 set to 1, because in 100, we look for 101 and 99, neither of them exist, set to 1. 4, we look for 3 and 5, neither exist, 1. 200, look for 201 and 199, neither exist, set to 1. 1, neither 2 or 0 exist, set to 1. 3, 4 exists, therefore set to 2. Or plus 2, depending on that is equal to the length of the previous plus 1 plus if the other chain exists, the new sequence length. Let's see. So 3 has 4, so the chain length is 2 now. Now when we set 2, 1 and 3 exist. So therefore the chain is 1 plus 2 plus 1, which is 4. But I wonder if this would work in a reverse example. So if we did like 5, 4, 3, 2. I'm trying to like break this up. 4, 3. Is there an example such that the chains will not connect by the time, or in a way that makes sense? And what I'm saying is that basically, is there a way that the chain order is not obeyed here? In the chain sequence. Like if we add a certain numbers in a sequence, they don't count as the full length of the chain. So we did 5, 2, 4, 3. 5 would be 1, 2 would be 1, 4 would be 2, 3 would be 1 plus 1 plus 2, that would be 4. So that works. If we added an item below before, oh gosh, I feel like there's got to be like a proof way to prove this now. If an item gets added before, and then we add a new one now that connects it, then it's fine. We just connect them. And if we connect the middle part, we get the top and the bottom. I think this works, but at the same time, I'm not confident that it works for all the time. I'm tempted to do let's do the big example. 7, 2, 5, 8, 4, 6, 0, 1. So the map would be 0 set to 1, 3 set to 1, 7 set to 1, 2 set to 1, 5 set to 1, 8 set to 2. What if we update all of them? Or at least we update the nearest neighbors. Because I think this example might actually prove my case. 4 is set to 2 because, or well, 3 actually, because there's both a 5 and a 3. 6 is set to, there's a 7 here, there's a 5 here. So that would make it 3. This 0 here already exists within the set, so nothing happens. And there's no 1, and there's no -1. And this 1 here would be set to 3. Yeah, so this clearly doesn't work out without updating. Might need to update the nearest neighbors as well. So let's try doing that. So if we did that, so 0 would be set to 1 still, 3 would be set to 1, as with 7, and 2. Well, no, actually 3 would be set to, 2 would be set to 2, as with 2, because 3 exists here. Then 5 would be still set to 1. There's no 4 or 6. 8 would be set to 2, as with the 7. 4 would be set to, well, there's 5 and there's 3. So now 3 and 5, so that's 2 plus 1 plus 2, that's 4. Right? 3, 4, and 5. No, 2, 3, 4, and 5, right? So now you get set to 4, you get set to 4 as well. Then 6 here, well, 5 is 4, 7 is 2, and therefore you are set to 7. You're also set to 7, and you're set to 7. And this 1 here, well, 2 is set to 2, and 0 is set to 1. So that only gives us 4, while updating you to 4 and 4. Is there another way to think about this? Did I do this correctly? The eternal question of all CS majors. Let's redo this, but with arrows so that I know when things change. So these are still set to 1. This sets to 2. This changes to 2. This 5 remains unchanged. This 8 gets updated to 2, as does this 7. This 4 sets to 2. No, this 4 sets to what? It's 1 plus 2 plus 1, that's 4. So you're set to 4. Because we have 2, 3, 4, and 5, which is the longest chain now. Then 6. 6, well, 6 has a 4 here, and a 7 here, and a 2 here. 7, 8, and has 2 through 5. So this is a 7. You update to a 7. And you update to a 7. The problem here is that even though we connect with 0 and 2, these values didn't get updated initially when they got there. When the other parts of the chain got updated. Right. So that's the problem. So connecting to 0 and 2 with 2 never having updated with the new length. The new length of 2 should be 7. Because 10 to the 9 is a really long, is just insane amount of operations, so we can't do that. What else could we do within the set? Because of course we don't want duplicates, so I think the set could work. But how do we keep track of the items within our set and their sequence length in a way that actually makes, well, sense in terms of the length? The longest length of a chain could be theoretically the entire chain. If we start from the bottom, let's see, going back to set idea, for each item in the set, check if it is the minimum. But how do we check if it's the minimum within the set? Well, if the item below it does not exist, then we know that it is the bottom of a chain. Then for each bottom value in the chain, search up until we find the end. I think that works. So then we check each item within the set. So assuming that all the items within the set are the same, or not all the same, assuming that they're all unique and the entire chain, the entire length is ascending, then we would basically just say, okay, you in the middle chain, no, you in the middle chain, no, 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 until we get to the bottom, the last item in the chain, or the bottom item in the chain, the minimum item. And we say, okay, we start from here and then we go. In that case, we would only have up to a maximum of O of n, 2 times O of n, right? Because let's suppose that bottom of the chain was added last. Then we'd have to go through the set again and basically say, okay, you exist, you exist, you exist, you exist, you exist, all the way back down. And that would go through all the n items within the set again. But that would only take 2n iterations. And so that maintains runtime. O of n runtime. Okay, okay, that's probably why it seems so familiar. I think this was also a problem that was talked about in CS career questions subreddit, or not subreddit, the Discord. I think this works because we're only checking the bottom ones and then we go up, and when we add, by the time that we add all the items into our set, then we know that all the items that should belong to a sequence will be within there, and we won't sort of miss an item in that case. And this would be O of n space as well, because we need to store all the items, assuming all the items within the list are unique. Cool, let's get started. With the code, so immutable set int of, and we'll call this our number set. And then we can say nums for each num, number set add num. Then numbers, well, we need a var longest chain is 0. And then we can say number set for each number. And this is going to be a little bit of a longer function, so let's separate it out. We can say if not number set contains num minus 1, then this is the bottom of the consecutive chain, or consecutive sequence. Then for num I in num plus 1 to, or while number set contains num plus 1, and we can say var sequence length is 1, sequence length plus plus, and then we can say if sequence length is greater than longest chain, then longest chain is equal to sequence length. So the idea is that we start at the bottom of the chain and we count up from there. So while the number set contains the next number, we can increase it, and we need to also consider var current num is equal to num, and we current num, and then we want to do plus plus current num, so we get the next number. So while, because we need to do this in order to actually increment the num, so sequence length plus 1, and then while the number set contains the next number, we increment the sequence length, and if it's longer than our longest chain so far, then we set it, and then we return our longest chain. Let's go ahead and run this code. So essentially for something like this, it was 03725. So this will get inserted in the same order, essentially, without the second 0. 0, we start from 0. There's no -1. We know that 1 exists, 2 exists, 3 exists, 4, 5, 6, 7, and 8 So they all exist, and then there's no 9, so we break it off at 9, 9 length, and then we increment through the rest of these items in the set. Well, 0 exists, so we don't consider those. Let's go ahead and run that example now within LeetCode. And then let's run a submission. Cool. And that seems to be the answer, at least to a reasonable degree. In any case, I hope you learned something. So this was LeetCode number 128, longest consecutive sequence. We used the set, and then we used the idea of basically checking for the bottom of any consecutive sequence and counting up from there. This results in an O of n runtime, though multiple passes, so you can consider it probably O of 3n. The first pass to add everything into the set. The second pass we need one pass in the worst case scenario in order to find the item, the minimum item at the end of the list, at the end of the set, and then one pass more to go through all the items within the rest of the set, again, in order to build up the longest sequence length. In any case, I hope you learned something, and I'll see you for the next problem.